Hello A-level students, this is work solutions for C2 January 2010. As always, have a go at working through them first and then have a look in the video for anywhere you didn't understand. So first one, which is usually the case for a C2 paper, they'll either start off with a basic integration or differentiation question. So here we've just got to do an indefinite integral. So x is going to become x squared over 2, and this minus 3 over x squared we're going to have to write as minus 3 to the power of x minus 2 because we need it as a power of x. So it's going to become minus 3 to the x minus 1 over minus 1, and then don't forget your plus c. So as you just tidy that up a bit, we've got x squared over 2 plus 3x to the minus 1, which you could write as 3 over x if you want, plus c. Good. Right, the next one. A sequence begins 1 3 5 3 1 3 5 3 ... and continues in this pattern. Find the 55th term of this sequence showing your method. Well, the way I think about this is we can see it's a periodical sequence, so it repeats every 4. So if we think, well, what's the remainder when we do 55 divided by 4? Well, that would be 13 remainder 3. So in other words, we'll have 13 lots of 1 3 5 3, and then the third term after that will be the 55th term. So I reckon it'll be 5. Then the sum of the first 55 terms, well, we've got 1 3 5 3 repeating 13 times. So that's 1 plus 3 plus 5 plus 3 is 12, I want to say. I'm in a C2 exam, so I'm going to check. Yep. Times by 13 will give us the first 52 terms, and then we've got to add on 1, 3 and 5, and that will take us up to 165. So that was doing 13 times 12 plus 1 plus 3 plus 5. Okay, question 3. You are given that sine theta equals root 2 over 3 and the theta is an acute angle. Find the exact value of tan theta. So you can kind of do this with your calculator, but given that it's 3 marks, really you should be using some kind of right angled triangle and thinking, well, if this is theta, if we know sine theta is root 2 over 3, then that must mean the opposite is root 2 and the hypotenuse is 3. So how can we find the adjacent? Well, we can use Pythagoras, so we can do 3 squared minus root 2 squared, which is 9 minus 2, which is 7. So that would be the square root of 7. Does that sound right? Yep. So all we have to do now is add up. Sorry, now all we need to do is find tan theta. So tan theta is going to be opposite over adjacent, which will be root 2 over root 7. And really we should rationalise that and call it, so if we times top and bottom by root 7, we'll have root 14 over 7. Okay, question 4. A sector of a circle has area 8.45 and sector angle 0.4 radians. Calculate the radius of the sector. Well, you need to know that the area of a sector is found using half r squared theta. So we know that equals 8.45, and we also know the angle is 0.4. So if this is 0.4, then if we times it by a half, we've got 0.2 r squared is 8.45. So on my calculator, I'm going to do 8.45 divided by 0.2, which gives me 42.25. So this is r. And then if we square root that, we get 13 over 2, so 6.5 centimetres. Question 5. Figure 5 shows a sketch of the graph y equals f of x. On separate diagrams, sketch the graphs of the following, showing clearly the coordinates of the points p, q and r. So first of all, f of 2x. So the first thing you need to do is think, well, what transformation would this be? So this will kind of be a horizontal stretch, but it'll be scale factor a half. So really it's not stretched at all, it's almost squeezed in. So if I try and do a drawing of that, so we can imagine P is going to be half the distance away from the y-axis than it was before. so that would be minus half. And the y coordinate would stay the same. Q is going to stay exactly where it is, and R, sorry this is getting messy, will be half the distance away from the y-axis, so that will be 2, 2. So your sketch should look something like that, although use a ruler and everything, and yours look a lot nicer. And then the next one is a quarter f of x. So if it's a quarter f of x, that's again a shrink. So if you like, it's a stretch scale factor vertically, but by scale factor of a quarter. So all of these points are going to be a quarter of the length away from the x-axis. So P is going to be minus 1, 0.5. Q is going to be 0, 1. And R will be 4, 0.5 as well. So it should look something like that. Okay. Right, question 6. Find the 51st term of the sequence given by. So they've told us the first term is 5, and then you've got this UN notation to tell us how to get from one term to the next. So if you like, it's saying the first term is 5. The next term, to get to the next term, you take your current term and add 4. So if we add 4 to 5, we get 9. Add 4 to 9, we get 13, etc. So to get the 51st term, well, we can see this is an arithmetic sequence. It's going up by the same amount each time. So our A is 5, D is 4, and we want the 51st term. So we're going to have to do A plus 50D. So 5 plus 50 times 4, which is 205. Part 2, they tell us is a geometric progression which begins 5 to 0.8, etc. And they want the sum to infinity. So you get the formula in your formula book. That's going to be A over 1 minus R. So our first term is 5, and then we've got to think, well, how do we get from, what do we times 5 by to get 2? So you can, in your calculator if you like, you can do 2 divided by 5, so that's 0.4. So it would be 5 over 1 minus 0.4, which is 25 over 3, or 8.3 recurring if you like. Alright, question 7 is an angles question, and I can see it's in degrees, so I'd recommend straight away making sure your calculator is in degrees for that question. So we've got triangle ABC, AB is 8.4, D is a point on AC, so it's the angle ADB is 79, BD is 5.6, CD is 7.8, find angle BAD, so they want this angle here. Okay, so I'd look at this and think, well, we've got an angle side pair that match up, and we've got one opposite our angle we want, so we can use the sine rule. So as we're finding an angle, we can say sine A over 5.6 has got to equal sine 79 over 8.4. So that means sine A will equal, so I'm going to do sine 79 divided by 8.4 times by 5.6, and I'll make that 0.654418 dot dot dot. So I'll put 0.6544 dot dot dot. So A will equal inverse sine of that, which gives me 40.9 degrees to 3 significant figures. And then they want the length B to C, so this length here, let's call it X. So we know angle A now. Is that going to be any help to us? Well, I think we're going to have to use this other triangle. So if we do 180 minus 79, that's going to give us 101 degrees. And then in this triangle we don't have any angle side pairs, so we'll use the cosine rule. So we're using the one where we're finding a side, which is a squared equals b squared plus c squared minus 2bc cos a. So in this case we've got x squared equals 5.6 squared plus 7.8 squared minus 2 times 7.8 times 5.6 times cos 101. and that gives me x squared is 108.86 blah blah blah. So x is going to be the square root of that, which is 10.43. Okay. Question 8. Find the equation of the tangent to the curve y equals 6 root x at the point where x equals 16. Okay, so if we're looking for a tangent to a curve, the first thing we need to do is differentiate it. So that root x I'm going to write as 6x to the half. So dy by dx will be 3x to the minus a half. Now we also need to know what's the gradient when x equals 16. So we're going to have to do 3 times 16 to the minus a half, which remember you can put that on your calculator, but you should know 16 to the minus a half is a quarter, so this is 3/4. So we know the gradient of our line. We also need a point on the line. So to find the y coordinate, I'm going to sub 16 into here. So it'll be 6 times root 16, in other words 6 times 4, so 24. So we can say y equals 3/4 x plus c, and then sub in 16, 24. So we'll have 24 equals 3/4 times 16 plus c. So 24 equals 12 plus c. So c is 12. So our final answer then is y equals 3/4 x plus 12. Okay. Question 9. Sketch the graph y equals 3 to the x. So all exponential curves have this same shape and they all go through 1 and they all never touch the x-axis. So you're going to want to make clear that tends towards but never touches the x-axis. Okay. So that's the same for any 2 to the x, 3 to the x. The only time it changes if it was a half to the x or something to the minus x, in which case it would be the opposite way around. Okay, use logarithms to solve 3 to the 2x plus 1 equals 10. So first thing I'm going to do is take their advice and log both sides. So we'll have log of 3 to the 2x plus 1 equals log 10. So 2x plus 1, lots of log 3, equals log 10. So then I think I'm going to divide by log 3. There's different ways to do this. You've essentially just got to get the x on its own. So that would be log 10 divided by log 3. Remember, don't be fooled into thinking that's log 7. There's no log rule for doing division. So then we're just going to have to take away 1 and divide by 2. So 2x will equal log 10 over log 3 minus 1. And then we've got to divide it all by 2. So I'm going to times it all by half and just cross out that 2. Okay, so log 10 divided by log 3 minus 1 times a half is 0.548. Right, question 10. First of all, differentiate x cubed minus 3x squared minus 9x. Let's do that. So 3x squared minus 6x minus 9. Hence find the x coordinates of the stationary point of the curve y equals x cubed minus 3x squared minus 9x. Show which is a maximum, which is a minimum. So this is our dy by dx, so we've got to make that equal 0 to find the x coordinates of the stationary points. So if I divide everything by 3 to make factorising it easier, so that will give us x plus 1, x minus 3. So we know the x coordinates will be minus 1 and 3. But they also want to know which is maximum and which is a minimum. So let's find the second derivative. So I'm going to differentiate our first derivative, so we'll have 6x minus 6. So if I sub minus 1 into this, I get minus 6 minus 6, which is minus 12. Now because that is less than 0, I know this is going to be a maximum. If I sub in 3, I'll be doing 6 times 3 minus 6, which is plus 12, and as that is greater than 0, this will be a minimum. Remember, if you get an answer of 0, you'll have to do the thing where you look at the gradient either side of the point. So it's not necessarily a point of inflection, but it could be. Okay. So now they want us to find an exact form, the coordinates of the point of the curve where the curve crosses the x-axis. So we're going to have to set the curve to 0 and try to solve that. So we've got y equals x cubed minus 3x squared minus 9x. Let me just double check that. Yep. And we want that to equal 0. So first thing we can do is factorise our x. So we know it was going to cross once when x equals 0 and once where this quadratic equals 0. Now, as they've said to give our answers in exact form, I think that's a clue that we're not going to be able to factorise this. So I'm going to put it straight into the quadratic formula. So minus minus 3 plus or minus minus 3 squared minus 4 times a times c all over 2a, so all over 2. And that gives me so either, oh, they wanted an exact answer, didn't they? So let's do 9. So we're going to have 3 plus root 45 over 2, or 3 minus root 45 over 2. So that's the point where it crosses the x-axis, and they now want us to sketch the curve. So we know it crosses at 0, and then it's got, let's see what those actual numbers are. 3 plus root 45 divided by 2 is about 4.85. So we know it's going to cross after the minimum, and we know it's got a minimum about here. And it's also got another minimum somewhere before, sorry, a maximum somewhere before, and then it crosses somewhere before that. So your curve should look something like that. So if they ever ask you to sketch something, usually what's important is where it crosses the axes. But if you found other things before, so for example here we found maximums and minimums, try and show that as well. So let's just double check it on the mark scheme. So there's that. So they want a sketch of cubic with 2 turning points the correct way up, x-intercept, so 1 negative, 1 0, 1 positive. Right, question 11. So figure 11 shows a cross-section of a school hall with measurements of the height in metres taken at 1.5 metre intervals from O. Use the trapezium rule with 8 strips to calculate an estimate of the area of the cross-section. Okay, so remember you do have the trapezium rule in your formula books. So the way I think of it, it's half the height. So our height is 0.75, it's 1.5, so half is 0.75. And then I think of it as the first y value plus the last y value plus 2 times all the y values in the middle. So the first was 2.3, the last was 2. In the middle we've got 2.7, 3.3, 4, 4.8, 5.2 and 4.4. Sorry, mine's a bit messy. And I think you can put that all in your calculator as one calculation. So the most common, most people write out this formula correctly, but the main mistakes are made when you're putting it in your calculator. So I make that 39.825. And I'm going to double check because I'm not 100% sure. And we have done something wrong. And again, I think I've missed off one of those 5.2s in my calculator. Yep, and that gives me the right answer. So you can see, very easy to make a mistake. Right, use 8 rectangles to calculate a lower bound for the area of the cross section. So this is kind of unusual. So I think what they're asking us to do here is imagine as this is going to be a lower bound, we cut these all off as rectangles, and we've got to work out the area of all of them and add them up. So each one's going to be 1.5 times by its height, so that's going to be 2.3 plus 2.7 plus 3.3 plus 4 plus 4.8 plus 5.2 for that tallest one, plus 4.4 plus 2. So remember, it's always the lowest height. So if we add those all up, we get 38.55. So that's for part 2. Again, I'm just going to double check. I've done something wrong again. What have I done wrong? So I did 2.3, 2.7, 3.3. For some reason I hit 1 instead of 4. So it's definitely worth checking all your calculations. So yeah, so that gives me 43.05. And then part 3, we've already done 2 estimates of the area. Now they're going to make us use integration to do it. So the curve may be modelled using this formula, where x meters is the horizontal distance away from the hall and y meters is the height. Use integration to find the area. So we've got to integrate between 0 and 12 minus 0.013x cubed plus 0.16x squared minus 0.082x plus 2.4. So I'm not even going to bother simplifying any of this because it's going to be a bit of a nightmare. So in minus 0.013x to the 4 over 4 plus 0.16x cubed over 3 minus 0.082x squared over 2 plus 2.4x, and that's between 12 and 0. Now you can see all of these terms are being times by some x to the 4, x cubed or whatever. So we know when we sub in 0 we're going to get nothing. So really all we need to do is substitute in 12 and then just write a big minus 0 on the end to show we know what we're doing. Right, so let's see if I can get this right on my calculator. So minus 0.013 times 12 to the power 4 over 4 plus 0.16 times 12 cubed over 3 minus 0.082 times 12 squared over 2 plus 2.4 times 12. And that gives me 47.664 minus 0. So 47.664, what was that, meters squared. Have I got it right? So that accepts anything from 47.6 up to 47.7. So 2 marks for the integration, 1 mark for subbing in 12, and 1 mark for this. So then they ask, comment on the accuracy of this model for the hall when x is 6. For the height of the hall when x is 7.5. So if we sub in 7.5 to find the height, so I'm just subbing it into y equals, so minus 0.013 times 7.5 cubed plus 0.16 times 7 squared minus 0.082 times 7 plus 2.4 is 4.181625 meters. So that's what the model predicts the height of the hall will be, but the actual height of the hall at 7.5 is 5.2 meters. So I say that's not a very good estimate and it's quite a way off. So that's your comment you need to put. What do they reckon? 5.30 found. Is that what we got? No. Having an absolute mare with a calculator after I've just tried to have a go at everyone for it. I've times by 7 squared instead of 7.5. Yeah, so all my 7.5s became 7s at one point. And if I hadn't done that, we would have got 5.3023 significant figures. So I guess their estimate isn't actually as bad as I made out to start with. So all you need to do is a comparison with 5.2, say whether you think it's accurate or not. Right, so on to the last one. So apologies for those calculator errors in every single part of the question. Okay, so final one is a nice log graphs question, it looks like to me. Okay, so since 1945, the population of many countries has been growing. The table shows the estimated population of 15 to 59-year-olds in Africa during the period 1955 to 2005, and they've even provided us with a source. Such estimates are used to model future population growth and world's need of resources. One model is, so P equals A times 10 to the BT, where P is P millions, T is the number of years after 1945, and A and B are constants. Okay, so show that using this model, the graph of log P against T is a straight line of gradient B. State the intercept of this model on the vertical axis. So what we need to do is log both sides of that equation they've given us. So we'll have log P equals log A times 10 to the BT. And then let's split up this right hand side, so we'll have log A plus log of 10 to the BT. Now, so our intercept I think is log A, but anyway, let's tidy this up first. So this basically becomes BT. There's two ways you can reason that. Either you can imagine the log base 10 and 10 to the power cancelling out, or you can imagine the BT dropping to the front and then knowing that log 10 equals 0. So we can see, if you imagine y equals mx plus c, because x is t is our kind of x variable and log p is our y variable, so we can see the intercept will be log a. So in answer to the question, state the intercept, this would be log a. On the insert, complete the table, giving values correct to 2 decimal places, and plot the graph of log p against t. Draw by eye a line of best fit on your graph. Okay, so first mark is just for logging those p values, which isn't too bad. So 2.32, so I'm doing log 209, log 277, 2.44, log 372 is 2.57, and log 492 is 2.69. Okay, and remember T is the number of years after 1945, so you can see they've given us all the right T values. So then, I'm not actually going to do this, but what you need to do is plot all those points on here, and you should get some kind of straight line, and then it's just a case of finding the gradient and intercept. Or maybe I will, because some of you struggle with that. So I need to do 10. What the hell have I got enough room? So 10, 2.12. Feel very free to skip through this part of the video if you like. So that's going to be there. 22.21, so that's going to be about there. 32.32, which is about there. 42.44, 52.57, and finally 62.69, which is about there. So you can see you get a relatively straight line. Now you will use a ruler in the exam. So we need to read off our y-intercept, which I'm going to say for me is 2. Yours might be a nicer straight line, so you'll get a better value. And then I'm going to try and find the gradient. So I'm going to use the two furthest apart points I can find, which is 0, 2 and 60, and that is about 2.7. I know there is an exact value, but yeah. Let's use 2.69. So then if we do, the gradient's going to be 2.69 minus 2 over 60 minus 0, which is 0.0115. So what they want in the mark scheme, so all of these plotted, so sorry, you get the marks for putting those into the grid, point for them plotted, a point for a line of best fit, And then, we didn't even look at the question actually. So use your graph to find the equation of p in terms of t. So we found our m was 0.0115 and log a was 2. So if log a is 2, a will be 10 to the power of 2, which is 100. So if we sub that all into our model, we'll get p equals 100 times 10 to the power of 0.0115 t. So what do they want? So they allow a value of c anything from 1.96 up to 2.02, so we're all right there, and a value of m anything from 0.01 up to 0.0125, so we're okay there. So 2 marks for that, 1 mark for log a equals c and finding a, and 1 mark for writing it out as an equation. Alright, so last part of the paper. Use your results to find an estimate of the populations of blah 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 in 2050. So 2050, if you remember it's so many years after 1945, that's going to be 105 years after. So we're going to have to sub in 105 into our equation. So I'm going to do 100 times 10 to the power of 0.0115 times 105, which is 1612.5, and was that in millions? It was, so that looks like basically 1.6 billion people. And the main thing we've got to spot is, because we're extrapolating very far from our data, it's always going to be unreliable. So essentially, if you're interpolating, which means looking at stuff within your results, so if they asked us about, I don't know, the number of people in 1972, we've got data for those date ranges, but 2050 we don't. So in fact there you're allowed anything from 1 to 2 billion approximately, as long as you're using t equals 105. Okay, right, hope you found that useful. Sorry for all the countless calculator errors or anything else I've done wrong, and again, let me know if you've got any requests for other papers. Cheers.